This is Mr. Ward. I'm going to do a third video on rotations, and this is my second fancy rotations video. And I'm going to go ahead and rotate this triangle around -3, -5. That's going to be my center of rotation. I'm going to use the tools from the last video. If you didn't watch the last video, you really should. We're going to be applying some generalizations to be able to do this rotation. Now, you could eyeball this, of course, from -3, -5, to 4, 2. We know that we can say from -3 to 4 is over 7 to the right, and from -5 to -2 is up 3 vertically. So to the right, up 3. This is going to be down, so down 7 instead of right 7, down 7, right 3. This would be left 7, down 3, and this one should be up 7, left 3. So those would be all of those points. Well, let's actually use the generalization for all of this. I'm going to copy the first 3 points of this, and I'll go ahead and start with a 180-degree rotation. Actually, before I do that, let me restate this triangle. So what I'm going to do is I'm going to restate this triangle in terms of -3, -5. So it's going to be -3 is going to be, my x value will be -3 minus 4 minus -3, which is 7. I'm sorry, that should be plus. I apologize. -3 plus, I'm going to change the color on this so we can tell what I'm doing. That will now be purple. Okay, turn that off. Actually, you know what? I think I need, yes, so that's now purple. So this point is in the right place. Now this one here is going to be, and then the y part will be -5 plus -2 minus -5. And that's basically -5 plus 3. So that's going to be -2. Okay, which is what we had. All right, so let's keep going with this. I'm going to go ahead and copy this structure for the x's. Okay. So that'll be 8 plus, not 4, but 8. And this one will be 7 plus, not 4, but 7. And one more. We'll deal with this one. 4 plus, which is that. I'm going to go back and grab the others. Let me expand this so you can see more of what the heck I'm doing. So I'm going to grab this structure, the y. I'm using the center of rotations y. It's going to be plus the difference in the y's. So it's going to be actually, go ahead and grab the whole thing. So -5. I messed up that last one. So this is still going to be -3. This one will still be -3, and this is still -3. Now they should be in the right place. Now I'm going to fix some more stuff. Let's see. -5 plus. Okay, -3 plus 8 minus -3. And -3 plus 7 minus -3. And that should be a -3. Now it's in the right position, and that should be a -3. There we go. Okay, so I've got them all in the right place. So I'm starting with -3. My mistake was I accidentally copied +3. And my earlier mistake was I was relating it to the x value here, not the x value of the center. So the key thing here is that you want to relate the x value to the center of rotation. Now I'm going to relate the y value to the center of rotation as well. So that's going to be -5 plus, okay, hang on, let me do it this way. -5 will be plus each of these. So I'm going to have -5 plus, in parentheses, 1 minus -5. this will be, this negative 3 will be negative 5. Oops, do that to where I want to be. Negative 5 plus negative 3 minus negative 5. And then over here, I will end up with this y being negative 5 plus negative 2 minus negative 5. And all of those points will be in the right place. Okay. Now, that's a big, crazy mess, but that will mathematically get you exactly what you need every time. So I'm going to copy this whole thing. And I'm going to now do the 180-degree rotation. So to do the 180-degree rotation, I'm taking every single one of these points, and instead of adding the difference, I'm going to subtract the difference for x and for y. Okay, for x and for y, all of these we will subtract the difference from the center of rotation. And it takes a little bit of patience, but it will get you where you need to be. And I should have all of these where I want them, and I'm not actually seeing them showing up. Here's the problem. I didn't turn that on. Now I've turned it on. I'll label them all. Those are the points. I'll go ahead and give that some lines. I think I need to scroll down a little bit so I can do that. Give that some lines around it. There we go. I've rotated this 180 degrees around this center of rotation. It was an ornery process, but I did it. Now, we're going to go ahead and take this triangle and we're going to rotate it around 90 degrees. I'm going to go clockwise first. And so what I'm going to end up with is my change. I'm going to have my center of rotation will be my sort of foundation of each of the points. And then I'm going to add the difference in the y's to my x value, and I'm going to subtract my differences in my x's from my y value. So I'm going to start, of course, I'm going to have negative 3, and that's going, I'm going to say plus negative 2 minus negative 3. That's the difference in the x's. And then I'm going to say, comma, negative 5. I'm leaving the other parts of the point so I can keep track of them. Minus 4 minus negative 5. And that point will be a rotation from 4, negative 2. So here's 4, negative 2. I have rotated it around like this. Okay. So let me just confirm that I've done that all right. Okay. So it's 4, negative 2. So the change in the, I think I see the issue. So it's still the change in the x. So I grab the wrong value there and I grab the wrong value here. This is the stuff you got to keep track of. So now that it didn't look right to me. So negative 2 minus negative 5 is the change in the y. And y was negative 5. 4 minus negative 3 is the change in the x, which of course is negative 3 here. 4 to negative 3. So now it's in the right place. So this point here is at negative 12 as y. So it's down 7 and over 3, just like it should be for 4, negative 2. 4, negative 2 is over to the right 7, up 3. Now we're down 7 and to the right 3. And that's exactly where we ought to be for that one. Okay. I'm now going to go on to the next point. Okay. We'll systematically do this. I'm going to say negative 3 plus 1 minus negative 5, and then comma negative 5 minus 8 minus -3. And that point is where it ought to be. So I was going from 8, 1 to 3, -16. So 8 is 11 over to the right. Now it's 11 down. 1 is 4 up from -3. And now we are, is that right? I'm sorry. Let me check this for a second. Now I am suspicious of this one. I'm going to pause while I check. I've checked it and I had tricked myself. So vertically, so to the right, I am from -3 to 8, which is 11. And vertically, I'm from -5 to 1, which is 6. Now I'm down 11 instead of to the right 11. And from -3 to +3, I am to the right 6 instead of up 6. So it is easy to lose track of which is which. But when you're suspicious, take a step back and take a look. All right, so I now have my second point of my triangle. I'm going to go to the third point of my triangle. I'm moving 7, -3. Currently, 7, -3 is 10 to the right and 2 up. So it should end up being 10 down and 2 right. So it should end up being at -15. Should be at -15, -1 is what I would predict. So 10 down instead of 10 to the right, and 2 to the right instead of 2 up. Okay, so should end up at -15, -1. So let's see if that's what happens. So we're going to start with our center of rotation. -3 is our reference point, plus 7 minus -3. And then, actually, I want to change that. I am sorry. Plus -3 minus -5, because that's the change in the y. And then I need -5, and then it's 7, -3. So I'm now going to subtract the change in the x's. So it's going to be 7 minus -3. And that should end up at -1, -15. And it does. So that's perfect. It's right where it ought to be. And so I've got my point. So let's go ahead and label those points. So we're at 0, -12. So 4, -2 became 0, -12. 8, 1 became 3, -16. And 7, -3 became -1, -15. And we have all those points. And you can go ahead and use this to tidy this up if you would like to. I'm going to leave this in its messy form because it'll be useful for me when I do a rotation 90 degrees around counterclockwise. So that's what I'm doing next. I'm going to rotate around 90 degrees counterclockwise. I'm using that exact same structure. Oh, I have one more point I have to deal with. I have to deal with this last point. The last point is the same as the first point, so I'm just going to copy the first point. Okay, let's go over to that last point. And there. And now I'm going to go ahead and make it a triangle. Give it lines. There we go. It has lines. It is a triangle. All right, let's deal with this last one. The last one, all I need to do is I need to change this to minus. So for this last rotation, I'm instead of, it's all going to start with -3 and -5. But instead of adding the change in the y's to the -3, I'm going to subtract. And instead of subtracting the change in the x's from my y value, I'm going to add. Okay, so minus, plus, minus, plus, and minus, plus, And this last one, I'm just going to copy my first point since it's the same point. Okay, here we go. And there we have it. I have now plotted my 90-degree counterclockwise rotation of my object around that center of rotation. So let's give it lines like a triangle. So I have to scroll down a little more. Come on, let me scroll down. All right, maybe I'm going to have to do some extra shenanigans here. Give me a second. Now, maybe I can get to where I can do what I need to do. Scroll down some more. Now I can do it. Still in the way. All right. There we go. And I've made my 90-degree counterclockwise rotation triangle. All right, there's one last thing I'm going to talk about, and I'm not going to actually do it, but I want to show you a little bit about how you might think about rotations that are not chunks of 90 degrees. And that is, just so you know, there is this thing called the polar coordinate system. And if you have, say, a triangle like this one right here, and you needed to rotate it around, in this case, we're going to deal with the origin for this. If you needed to rotate it around the origin, something you're probably going to need, if you want to do something other than 90-degree chunks, you're going to need the polar coordinate system, and you need to learn how to use it. Now, it's really a neat system because we can rotate in other chunks of degrees. So we could rotate a point that's currently at 8,1, we could rotate it 30 degrees or something. I'm actually going to turn that one off and I will make a new point. I'm just going to rotate one point. I'm going to rotate the point. And in the polar coordinate system, we actually give the points a distance from the origin. So I'm going to say 6, comma, and we'll make it 30. Okay, I think it may be objecting to something I've done here. So I'm going to make that, I'm going to change it to what's called radians. Okay, 6 comma, and the pi over 6. Okay, that doesn't seem right to me. Okay, because that is not pi over 6. All right, so I'm going to come back and do more on this. We can skip this for right now. But basically, you would need to, and I'm not very experienced with the polar coordinate system, but basically, all the points are based on a distance, a radius distance. So these are all circles from the center, and some sort of measurement of the angle around the circle. Okay, so there's something I am missing about how I am setting up my angles. So let me see here. That's pi. Let's make that over 2. That's actually closer to where I want it, but it's not really where I want it. So something is a little off for what I am trying to do. But what you would basically work on once you understand, and once I understand the polar coordinate system a little better, is you would be able to rotate in smaller chunks around this system. So it's a different system for graphing things. It's basically how far are you from the center at the origin, and how much have you rotated around this angle. I'm going to set that aside for right now. I hope that this final video on rotations has been helpful, and I'm going to make a practice video for you.